So we've been talking about fractions and about comparing them and finding equivalent, which means equal fractions, right? Today we are looking at comparing fractions that are different sizes, okay? So instead of finding common ones, guys, I want pencils and everything down. I see too many people drawing, okay? So when we look at a fraction, the bigger the denominator, remind me, is the denominator on top or bottom? Mary?
Bottom.
Bottom, okay? So, like denominator, down, the number on the bottom, okay? So the denominator, the bigger the denominator, the smaller the piece. So everyone say, the bigger the denominator, do it with me.
The bigger the denominator,
The smaller the piece.
the smaller the piece.
Let's do that one more time. The bigger the denominator,
The bigger the denominator,
the smaller the piece, okay? So if I have halves, my denominator is 2, right? If I have fourths, my denominator is 4, and my piece is smaller, right? The bigger the number, the smaller the piece, right? Do you guys see that? But then if I even look at these two, I have even bigger denominators. I have 6 and 8, and they're still smaller, right? Then when I go all the way to 12, it's the smallest fraction I have on my fraction circles, right? Yes, Keegan?
the denominator is going by 2.
I know I did it on purpose. Okay, so we have our denominators. The bigger they get, the smaller the piece, right? That's going to help us when we know how to compare them, okay? Okay, so on page 81, it's wanting us to, it says each of the rectangles below is one whole unit. So the whole rectangle, including the blue shaded part and the clear part on the end, is one whole unit. That means they are all the same size. Just like when I look up here, this is one whole unit of my fraction circles, right? All of these are the same size. So they're all one unit. They're just broken into different parts. And maybe a part's shaded. So it'd be like if I trace this, okay? But I took this out. There's still a whole unit there, but it's not completely filled in. Does that make sense? So each rectangle, the whole thing is one whole unit. Okay, they're all the same size. Label each strip with one of the following fractions. We have 1/10, 9/10, 7/8, 4/7, 2/5, or 1/8. Okay? Use benchmarks of 0, half, 1, and 1 to help you. Okay? So what it's saying there is we all have these long rectangles, right? And I'm going to try my best to replicate. Now, this is what your page looks like, right? Each rectangle is a whole unit, okay? We are taking our list of possible fractions and seeing which ones of those could be similar, okay? Could represent these fractions, okay? So when it says to use benchmarks, it means points that you know, okay? So we can kind of see, we know that this is 0, right? We know that this is 1. So I want you to put a 0 and a 1 on each rectangle at the end, just like mine. Those are easy, right? 0 is on the left, 1 is all the way at the end. Now, in the middle, I want you to put a half. See this? All my halves line up. Look up here. My halves line up. Look at where my halves are and try to make them like yours. Okay? Okay, so once you do that, now we look. We want to see which fraction is closest to 1/10, 9/10, 7/8, 4/7, 2/5, 1/8, or 1/8, okay? So first things first, what is my smallest fraction? We want to find the one that has the biggest denominator and the smallest numerator. So what's my biggest denominator? Boy Leon, what's my biggest denominator?
1.
No, my biggest denominator, the one on the bottom. We have 10, 8, 7, 5. Which one's my biggest denominator?
10.
10. What is my smallest numerator? We have 1/10 and 9/10. Which one's my smallest piece? Keegan? 9/10, right? Or wait, 1/10. Sorry, I thought 1/10 is my smallest piece. Okay, I was thinking something else in my head. So our smallest piece is going to be our 1/10 of a fraction. So which one is my smallest one? Look at yours too. Which one is my smallest? What number? Mary?
5.
Number 5. So number 5 is my 1/10. Okay? You guys see that? Number 5 is 1/10. So you're going to write 1/10 on the line next to number 5. And notice, I didn't put 1 and then use the line as a fraction bar. The line isn't a fraction bar. The line is where your answer goes. Okay? Now, what is my next, what's my next smallest? Mary?
6.
We don't have a 6. Oh, 6? Yes. What is my next smallest fraction? What's my next largest denominator?
9/10.
No. Bella?
1/8.
1/8. Because we have a big denominator of 8, but we only have one piece of it. Does that make sense? So, Mary told us that number 6 was our next smallest, right? So we have 1/8 for number 6. Okay? This is just kind of going from ones that we know, okay? Now, the next thing I want us to do is which one is closest to 1/2 of our given fractions? We have 9/10, 7/8, 4/7, and 2/5 left. Which one is closest to 1/2 unit? Boy Leon.
9/10.
9/10. Which number, fraction bar, is closest to 9/10? Or is it closest to a whole, Ben?
9/10.
Right, but which one? 1 through 6? Well, really 1 through 4 because we already did 5 and 6. Which one is closest to a whole being shaded in? 1. Just a barely, but yes, 1. So we have 9/10 over our 1, okay? Now we have 7/8, 4/7, and 2/5. Number 4 is close to a whole, right? Number 4 is close to a whole. So which other fraction, 7/8, 4/7, or 1/8, is closest to 1 whole? Bella?
7/8.
7/8. So number 4 is going to be 7/8, right? Now, this next one, we want to look at this. What is half of 5? Is there exactly a half of 5? No, but 2 1/2 is half of 5, okay? Because if we look, the 2 lines we have left, 2 and 3, are both close to our halfway benchmark, right? 1 is just over half and 1 is just under half, right? So if I have 2/5, do I have more than a half or do I have less than a half? Let's look at our fraction circles. Ouch. So is that half? What I still have up here? Is this half?
No.
No. So 2/5, is it my 2 or my 3? Everyone?
3.
3, because it's just less than half. Okay? That's how we use these benchmarks, by looking at, okay, which one's close to a whole, which one's less than half, and things like that. So then that means my 4/7 is my number 2. Okay?
Done.
Do you all see how we did this? And how we used our benchmarks of 0, 1/2, and 1 to help us find where the fractions belong? Yes? No?
Maybe so.
Okay. So, that was our in-book lesson, but I want you guys to hold on. Okay, so when you get to home links today, you guys are going to be given a problem, and you guys are going to be saying whether it is correct or not, and then solving it correctly, okay? So, we are going to look, I want you guys to get out your home links actually, page 77, and go to that page. So this is what you see on page 77, right? So what it wants is it wants you to see which of Karen's answers is correct. So you write it, and then it says to draw on Karen's diagram to make it clear how the pizza should be distributed. So what I would do, okay, I'm giving you a hint here. What I would do is I would say, so we have Karen and her 3 friends want to share 3 small veggie pizzas equally. Karen tried to figure out how much pizza each person will get. There are 4 people because we have Karen and her 3 friends, okay? You have to include Karen. So what I would do is draw on her diagram. They want us to use her diagram that's up top. And this is what I would do. In this square, I would put a K for Karen. Okay? Then I would just make up kind of names. So I'm going to say Susie, Martha, and Bree. Okay? So now we're going to do the same on this one. Karen, Susan, Martha, Bree. Can you stop, please? Karen, Susan, Martha, Bree. Okay? This is how I would show how I distributed the pieces of pizza. Okay? And this will probably also help you answer that first part of that question. Then it says, Erin and her 7 friends want to share 6 small veggie pizzas equally. How much pizza will each of the 8 children get? So now you can use the back or area up at the top to draw your own diagram and see how to do it, okay? How will you get, or who will get more pizza, Karen or Erin? So you're going to see what fraction of pizza Karen gets, what fraction Erin gets, and who got more, okay? Does that make sense? And then you are going to do the practice. When you look at math boxes on 82, number 1, you are identifying equivalent fractions. So you get they tell you to find 2 equivalent fractions for 1/3. And then 2 equivalent fractions for 1/4. Then they say that for number 2, you need to circle the shapes that have at least 1 pair of parallel sides. And then it wants you to solve number 3 by estimating, doing a number model, and solving. We did that in my group, in my station group last week. Remember? Do you guys remember that? Okay. Then you are doing expanded form. It even gives you an example of what expanded form is. And then they want you to fill in the fractions on the number line. Okay? So, then I will explain Math Masters in a minute, okay?